This pertains to the maximum and the minimum values that you can find within a quadratic function. This is on Student Journal page 32. How do you know your graph or your parabola has a minimum value or a maximum value? This one pointing up has a minimum because it has a lowest point, and this one that points down has a maximum because it has the highest point. To find the minimum or the maximum value, you only need the vertex. Whether your parabola points up or points down, all you need is your vertex, and that vertex tells you your minimum or your maximum value. Domain is how far left or right your graph goes. That graph is opening forever to the left, so it's approaching negative infinity. And this graph is opening, it does not appear that it is, but it is opening forever to the right, so it approaches positive infinity. In algebraic terms, you would say all real numbers. For Algebra 2, we need to use interval notation, and this is how you write interval notation for all real numbers. Every parabola that we will do will either point up or down, and the domain for every parabola that points up or down is negative infinity to positive infinity with parentheses around it and a comma in the middle. If your domain is from left to right, then your range is up and down. As I look at this graph is going up forever. This graph is going to positive infinity. Does it have a beginning point? Yes, it does. Your domain is your x's and your range is your y's. This is how you write it. It begins at y, includes y, that's why you have a bracket, and it never stops or it goes to infinity. So that's why the range for this one is from y to infinity. The range for this one over here, the graph of this parabola is not at positive infinity at all. It is at negative infinity. That's why the range for this one looks like this. I may not have pointed out previously when you're talking about domain and range, you're always going from least to greatest. That's why this says negative infinity to positive infinity. It would be incorrect to put positive infinity and then negative infinity. So that's why here my negative infinity comes first, because that's the smallest value that this graph approaches. Then it goes from negative infinity and it stops. Where does it stop? It stops at this y value. So that's why the range for this function is from negative infinity to y. And that y value comes from your vertex. Now, the increasing and decreasing, I tried to color coordinate with an ink pen to show you for this graph, it's decreasing to the left of this x value, and it's increasing to the right of this x value. Same thing for this one. It's increasing to the left of this value, it's going up. It's decreasing to the right of this value, it's going down. So those are facts that you need to know. I want to continue and talk about intercept form, and then we'll do some examples. This is still on page Student Journal 32. The three forms now that you need to know are vertex form, standard form, and intercept form. In intercept form, the p-values and the q-values are your intercepts. If you look here, this is p, this is q, your x-intercepts. These values are where your graph or your parabola will cross the x-axis. The axis of symmetry is halfway between these two intercepts, so that's why the formula for the axis of symmetry here is x equals p plus q divided by 2. So your axis of symmetry is x equals the average of your two x-intercepts. Lastly, we know that that parabola will open up if this a value is positive, and it will open down if this a value is negative. We're going to do these three examples, 1, 2, and 3. We're going to follow these instructions to do these three examples. I want to point out quickly, vertex form, standard form. I believe what I'll do is sketch the parent function for 1 and 2 lightly with a pencil, and then move that parent function according to these transformations. I have completed some transformations to graph these two functions. To graph these two functions, the first thing I did was sketch the parent function. For this one, I looked at this vertex form. I can see the transformation is left 1. So I took every point left 1. And what I'll do in just a moment is I will erase this parent function and then draw my new function. This one was a little bit more complicated. There are 4 transformations. I did them one by one. The first thing I did was reflect the parent function across the x-axis. Of course, this point stays where it's at. This point is 1 unit away from the x-axis, so I drew a point that reflects 1 unit away from the x-axis, and same thing here. Next, this 2 represents a vertical stretch of 2, which means you multiply your y-coordinate by 2 instead of -1, 1 or -1, -1. You multiply your y-coordinate by 2, so I have -1, -2. Same thing for this point here. Instead of having 1, -1, you multiply your y-coordinate by 2, you have 1, -2. So now my 3 points I have that I'm going to translate are these 3 points here. And how did I translate them? Right 4, down 5. I counted over 4, down 5. That's my new vertex. I counted over 4, and my graph wasn't big enough for down 5, so I went down 4, 5. And same thing for this one, they should be on the same line. For the first problem here, the vertex is this point, -1, 0. The axis of symmetry is the line that goes through the middle of my black parabola. It goes through the vertex of my parabola. It goes through the x-coordinate of my parabola. The axis of symmetry is x equals -1. In vertex form, the axis of symmetry is x equals h. And x equals -1 because remember, left 1 is my h value. Now, do I have a maximum or a minimum? That's what this stands for here. Does this graph have a lowest point or a highest point? Well, it has a lowest point, so that means it has a minimum value, not a maximum value. And that minimum value is the y-coordinate of the vertex. So my minimum value is 0. For my domain, remember we said on the previous notes that I highlighted these here on Student Journal 32, we said our domain was -infinity to +infinity. For all the parabolas that we're going to be doing, you may want to refer back to that page as we're looking at these problems. The range deals with the y-coordinate. Does that black graph approach -infinity or +infinity for your y-coordinates? Hopefully you can see the black arrows are pointing up, so it's going to +infinity. +infinity would be my largest value. Then where does it start? Where does the range start? Where does the range start on the y? It starts at 0. So my graph is from 0 to infinity for the range, and it includes 0, so you must use a bracket. Increasing and decreasing deals with the direction that the graph is going from left to right. I like to draw arrows to demonstrate increasing and decreasing. And you're talking about in relation to your x-coordinate of your vertex. Where is my graph increasing? It's coming down, going up. So it's increasing to the right of -1. Where's the graph decreasing? It's going down here. So it's decreasing to the left of -1. I'd like for you to try the same thing for question 2. Write down all your blanks here and then fill them in and come back and check your answers. For question 2, I found the vertex to be 4, -5. Remember, that comes from my vertex form. 4, -5. Right 4, down 5. The axis of symmetry goes through the vertex of my parabola. It goes through the x coordinate of my parabola, so my axis of symmetry is x equals 4. Remember, it is a line, so you must write it as a line. Because this parabola has a highest point, it has a maximum value. The maximum value is your y-coordinate of your vertex, so that's -5. The domain, how far left or right does this graph go, is -infinity to positive infinity. My range, since it's pointing down, it's going to -infinity. Negative infinity would be smaller than any number that I would have within this coordinate plane. So -infinity goes first. Where does my graph stop for my range? Remember, range is your y value. My range would stop at -5. So the range is from -infinity to -5, including -5. I drew the purple arrows and the L and the R for my increasing and decreasing. Where are my arrows increasing? To the left of the x coordinate of 4. Where are they decreasing? To the right of the x coordinate of 4. The first thing I need to do when given a quadratic function in standard form is to find the axis of symmetry. I named A, B, and C. I filled B and A into the formula for the axis of symmetry. Negative B would be -3, which is 3, over 2 times 3/2. I multiplied 2 times 3/2 and got 6/2. I simplified 6/2 to get 3. Then 3 divided by 3 is 1. So the axis of symmetry is x equals 1. For my vertex, I now know that 1 is the x coordinate of my vertex. I will substitute 1 into this function to find y. I will also draw the axis of symmetry on this graph. I substituted 1 into the original function, and I got the answer y equals -5/2. So my vertex is 1, -5/2, and that's this point here. The next thing that I did is find the y-intercept. Remember, the y-intercept is your c value. So my c value was -1, so my y-intercept is -1. I plotted that point here. The reason why I chose to find my y-intercept is because I know that for a parabola, whatever is on this side of the parabola, there's a mirror image on this side. So that means if 0, -1 is a point on the parabola, its mirror image is also a point. The mirror image would be on the same horizontal line and would be the same number of units away from the axis of symmetry that I have drawn. So this point is 1 unit away from the axis of symmetry. That means there's also a point 1 unit away on the other side. And that gives me my 3 points that I can use to sketch my parabola. I will finish by finding the remaining information that we found in question 1 and question 2. I found that this graph has a minimum value because it has a lowest point. Remember, the minimum value is always the y-coordinate of your vertex. The domain from -infinity to positive infinity is how far it opens from left to right. The range, since this graph opens up, it goes to positive infinity. My y value, that's the lowest point, or where it would begin, is -5/2 to infinity. Where's it increasing? It's increasing to the right of 1. And where's it decreasing? It's coming down or decreasing to the left of 1. I don't know why there's a negative sign there.